Hello everyone and welcome back to another Universe Sandbox video, and today we are going to be doing an idea which one of you guys requested in Discord. So this is suggested by the user Mundalafi the Gamer. I hope I'm saying that right, apologies if I completely butchered that, but yeah, they said a nice little simple test to do here with a basic supernova in the solar system, because Universe Sandbox, or Universe Sandbox 2 as it was formerly known, has become more modern and realistic. So if you're going to do a supernova test, don't forget to unlock all of the mass and the size of the objects. So I've already pre-done that before this, before I started this recording. So all the objects, they've all got calculated radius switched on. None of the objects are using the lock feature, so we should get a nice, good supernova here without any of the objects surviving with ridiculous numbers or anything. So without further ado, I mean, all we need to simply do is press one button for this one. So all we're going to do is slow down the time. We're going to go, we'll go to like almost real time actually. Why not? So about 1.1, 0.7 seconds, so just under real time. Now we are going to want to go to explode, if I can remember where the button is. There it is. Actually, you know what? I might actually, let's drag that down here, put it next to the laser button. There we go. So explode. Right, and all we simply need to do is supernova, press the sun, and there you go. So all of the planet orbits already upset, so we'll just leave them like that so we can see. So there is a supernova that is now, oh, we got the nice coloured one as well, but yeah, supernova at the centre of the solar system. So what we're going to do is, I mean, let's have a little view from Earth to start off with, actually. So here we are. Obviously, no more sunlight, so not looking good. Let's go ahead and land down, because that's something we didn't used to do. If you deleted the star, it used to give the planets light, but now if there's no star, if you have one of the options switched on, it's actually just darkness, right? So where exactly is... Aha, there you go. So that's where the sun used to be. So imagine seeing that. Right, so speed up a little quicker. So it's going to take some time for it to arrive. Okay, so once we go up to about 15, 16 seconds, then you really notice it starts to set off there. So let's just keep it going a little further now. So view from the Earth. We'll probably sit on the Earth until the Earth is consumed by this. We may actually be able to spot Mercury or Venus, as they are closer, start to evaporate. So have a little look at Mercury here. Keep an eye on its temperature gauge, because I think it's going to go a little crazy here. So as we can see, that radius, for instance, is switched on. So yeah, the supernova should start to upset this thing eventually. So let's see how that does. Venus as well should, in theory, get quite hot from this. So let's go ahead and let it speed up a little more. So yeah, imagine having that on the floor, just looking up from the sky of Earth and just having that huge thing in the sky. I mean, that does look awesome. So let's keep going. I think the Earth is about to be consumed by it. I mean, it's getting close. So as we can see, yeah, it looks like the Earth is now inside the cloud of death. So let's zoom out, go back to labels in orbit. So right, there we go. Okay, so we can see the Earth is already increasing in temperature. So if we have a look here, actually what we should do as well is, how's Mercury doing? I'm guessing Mercury should be getting hotter as well here. So yeah, so that is increasing. So what we'll do is, I think we should be able to keep an eye on the gauge just by having all the planets up here. So can we do that with all of them? So let's see. Venus, we want to go to surface. And we obviously want temperature. So do we want to press that button? There you go. I always forget how to do that one. So then same with Earth. Again, click the button. We'll do all major objects, so I won't do asteroid belt objects and things like that. So obviously I should say the 9 main planets, because we do have planet 9 in this simulation as well. So we'll have that one. So again, Jupiter, Saturn. Obviously, we're going to be looking further down the list as the supernova goes off. So there you go. We'll throw Pluto in as well. So why not? There we are. Pluto. Yes, please. And you know what? I'll do a few outer ones. So we'll have Eris, Sedna, and Planet 9 as well. So Sedna over here. Obviously, the ones at the bottom are probably not going to be affected as much. I mean, I'm expecting Planet 9 to probably survive this, because it normally does. But I haven't actually tested it in this version of the game, so this could get quite interesting. So, back to the supernova in the middle. Obviously, let's just lock back onto... we'll just lock back onto Earth, I guess. So, alright, there we are. Click play. Now we'll watch as the temperature. So we're looking at Mercury, Venus, Earth at the moment, currently. If we slow it down, we can see Mars. We can see Mars is starting to warm up. But yeah, the first 3 planets is where we are going to be paying attention mainly. So Mercury, for instance, closer to the supernova, it's getting heated up quicker. Looks like Venus is colder than Earth for some reason. That's a little bizarre. So Mercury, obviously, yeah, the face it's facing that side, it's not looking good. I mean, that is that is very hot. So if we look 12,000 degrees and increasing. So eventually this should in theory just vaporize at this point. Once it gets just hot enough, I mean, that thing is just, that's not looking good. So Venus again. So the supernova almost creates like a tightly locked effect. Whichever face of the planet. Oh, Mercury, looks like Mercury's had it. So Mercury's been destroyed. So Venus is next on the list. So again, same problem with that. But you can see it's almost like a tidal lock effect where whichever face is facing the supernova directly, it's going to get hurt a lot more. So you can see Jupiter, Saturn, Uranus and Neptune are still sorting themselves out. We've got Pluto, still cold. Obviously, all the other ones are still cold behind Pluto. So the furthest down we can go currently is Neptune. So even good old Neptune, though. So where else? So you can see Jupiter's actually glowing hot now. You can even spot it from this distance. You can see. Oh, dearie me. So I'm guessing that should survive. Normally, Jupiter's quite good at surviving. The inner planets won't. I don't think so. How's Earth doing? Yep, completely had it. I think the inner solar system. So how are we looking? So Venus is still hanging in there. How's Uranus and oh no, Earth looks like Earth's about to go. Earth's gone. I think Venus may have started off at a colder temperature, so that's why it's not done that. But we can see Uranus as well. Venus isn't going to last, that's for sure. Neptune is also glowing hot. You can see it. Oh, that blue looks gorgeous when you heat it up like that. So there's good old Neptune. But yeah, if we just zoom back into Venus, closest planet to where the sun used to be, I'm not expecting much from Venus. I think it's gonna pop any second now. Yeah, that's been disintegrated. So we can see Venus has gone, Mars has gone. Okay, so now we're into the outer solar system area. So how are we doing? We've got Jupiter. Oh, something else just vaporized. So what was that? So Jupiter, Saturn, Uranus, Neptune, Pluto, Eris, Sedna, Planet 9. Okay, I think it's just the that's because we obviously changed the object we were focused on. So I'll just keep sitting in the middle then. So obviously no more orbits, trails. Can't really see them, but yeah, let's just keep click and play. See where we are. So another sort of pause. So Jupiter, Saturn, obviously Uranus also ultra hot. The Uranus one's really weird because it's tilted on its side. Neptune, Pluto, 2,000 degrees at Pluto. So where are we? Pluto? It's a purple trail object over here. Oh dear, even Pluto at that distance is getting it now. So Pluto, further out we can see Haumea. We can see some of the other dwarf planets are also glowing hot. How's Eris doing? Okay, 23 degrees. So Eris hasn't received the blast yet. So we'll keep an eye on Eris. So, and no, it definitely has received the blast. That's the average temperature, remember. So that's now going up. Okay, so that's going to warm up. Sedna, I'm not expecting much from it yet. How are we doing? So Sedna and Planet 9. Oh, no, Sedna, 40 degrees. Planet 9, 1,900. All the way over here, Planet 9. And it's already receiving the blast. So that's pretty crazy. But let's go back down to the other planets. So we've got Jupiter, Saturn, Uranus, and Neptune. So will Jupiter and Saturn survive is the question I want to know at the moment. So how are we doing? I mean, that is a very intense... Look at what is going on there. Let's actually have a zoom in on that. What was all that about? Look at that. I mean, that looks awesome. It's a bit glitchy, but... Oh, dear. Yeah, it is losing material, though. 0.99 Jupiters. So we're only travelling at a few hours, remember. So obviously the bigger planets are going to take longer to disintegrate. But yeah, that looks pretty awesome. How's Saturn? Look, let's see if we can locate Saturn. Yeah, Jupiter, not looking good. I mean, that ice, although I say ice hot, that ice blue hot side is just looking crazy. I mean, it looks awesome in the image above. I mean, in this little part on the top right of all that going around. That does look awesome. So, where it is, so yeah, it's losing mass. Saturn, I'm guessing same problem with Saturn. So, how are we doing? Yep, same issue. I mean, it's just pretty crazy, isn't it? That does look awesome. So, yeah, we can just see the temperatures all going here. So eventually we'll have to keep an eye on Uranus first. Uranus is the one with the least mass. So I'm expecting Uranus to be destroyed the quickest. That's what used to happen in the older versions, but we'll have to wait and see what happens. So we can see it's losing radius. So Uranus is losing some sort of material. How's Neptune doing? So Neptune 17.1. Again, that glitch is going on at Neptune. I mean, that does look cool though. So how are we doing? Let's speed it up a little more. So Jupiter's at 40,000 degrees there. That is... So let's switch back to Jupiter. Oh dear, oh dear. So yeah, we can see even the mighty Jupiter. It's losing mass. It's losing mass very, very fast. So let's keep it going. So now we're traveling at over a day a second now. So we can see everything's sped up a bit. Pluto is still hanging on in there. I'm not expecting much out of Pluto, to be honest, if it actually makes it to the end of this. I mean, there's no way. I mean, yes, Pluto's going to go. Eris... So Eris is obviously further out than where Pluto was. Are you losing mass? I'm guessing it probably will be. I don't know if it is. Yeah, it is losing mass, okay. Sedna, even the old Sedna at the furthest reaches of the system. Sedna, still not doing it. Where's the Goblin at? That's quite far out as well. Okay, oh, okay, so it's not too bad here, yeah? Okay, interesting. So, obviously the other planets, so... Look at Planet 9, what is all that about? So Planet 9's not getting too hot in temperature, 2,000 degrees, that's definitely not going to be enough to disintegrate it, so... Planet 9, how you doing? Yep, Planet 9, yep. Oh, no, it has lost something, it's lost 0.1 so far, so maybe Planet 9 is getting affected then. So, let's keep it going now. And now we'll just, we'll speed it up as far as we can go now, so let's just really let it go. So let's see if they survive or not. Oh, it looks like Jupiter may have calmed down. Okay, interesting, right, so Jupiter... So it's lost over half its mass, though. It's only 10 masses of Earth. Wow. Saturn. How are we doing at Saturn? 0.184 Jupiter. So how much is that in Earths? Normally Saturn's about 57 Earths. So that's at 58. Okay, not much has happened there. What about Uranus? 14.4. Okay, so Uranus hasn't lost much, or pretty much anything. Neptune's still 17.1. Interesting. So Jupiter got more of the blast than the other ones. That's quite bizarre, isn't it? So, right. Let's just let it roll now. So let's just speed it up, see how far we go. Obviously, we can close all these now because they're going to cool down since the supernova is pretty much over. Uranus and Neptune are just broken, so let's just do that. Jupiter's looking quite with that little spot on it. What's that all about? So, right, there we are. So, let's go ahead and just, let it go. So, everything's just going to break away, just to let it freshen out. So, there we go. Supernova's gone. So, Control, Delete, get rid of any particles. Right, so now if we line them all up, let's go back to, obviously, Studio. So how are we looking on the sizes? So Jupiter... Oh, no, it's still losing radius. Even after... Interesting. Even after the nova's gone, they're still... What's that all about? So Saturn, how you doing? Maybe they picked up some mass, some of these. I mean, Saturn's not really having any changes, but Jupiter... What is going on with Jupiter? I mean, maybe it's a glitch, because that does seem pretty weird. So yeah, Jupiter's smaller than Saturn now. So let's just speed it up to just like stupid lengths of time. So why is Jupiter disintegrating? That doesn't seem right. Yeah, I don't think that... I'm not sure that's correct. That is really random. So let's just go stupidly quick now. So is Jupiter eventually just... Oh no, so Jupiter's finally stabilised now. So that's interesting. So Jupiter for some reason sits in between Uranus and Saturn now. That is bizarre. Let's see. So stuff after Planet 9 down here. So some of the dwarf planets are still hanging in there. I mean, okay. So Pluto completely dissolved, but stuff like Eris, Sedna... Oh no, Pluto is there, never mind. So Pluto actually lost some of its size. It looks very scorched though. Surface texture on it's completely reset by the looks of it, so that's really crazy. But yeah, we have lost a lot of the members of the solar system, so interesting stuff. But let's actually run the test again. We'll run it in a bog standard simulation this time, see if we get any different results. So let's do that. All part of the experiment. We'll try it in a different one. So for instance, again, we don't need to... Everything in here is already preset for us, so we can literally just simply press the explode button, press a sum. We'll let it run a little quicker this time because we were more interested in the end result. The inner planets are already gone, so crazy stuff there. Asteroid belt is obviously going to break off into God knows where, so let's let that go. So Jupiter broken away from the sun. Look at the asteroid belt just all shooting off now, so let's just keep it going. So again, the gas giants have all survived it this time. Eris, Sedna, Pluto, so it seems like the Kuiper belt objects can now start surviving. I do want to try that with a different star. I want to see if it's just the sun that does it, or if we put a larger star in, does the supernova cause more damage? So for instance, this is what's happened this time. So again, is Jupiter losing any mass still? Or was that just a random occurrence? So let's speed it up really, really quickly. Was that just an anomaly what we had? I think it may have been. It's so interesting. So all the other planets are all fine though. Obviously no Planet 9 in here. But obviously if these guys would survive, Planet 9 would survive at this distance. So again, similar results with all the gas giants surviving that time. Right, so now, I'm guessing that's going to happen every time. So what we're going to do this time, we're going to throw in a few larger stars. So for instance, just quickly pause, get rid of the sun completely. So we'll level up with a few stars. So I'll start off with Arcturus here. That's obviously a larger star straight off the bat. And then what we'll do is simply just do that, pop it straight away, click play, and we'll see if that star causes more damage or not. So let's let it roll. So let's see if the asteroid, the outer Kuiper belt objects, some of them have definitely disappeared. Eris has gone this time. Okay, so already looking like more the bigger stars are causing more damage. I don't know why Pluto's still hanging on. Oh, no, never mind. Okay, so we've just got the 4 gas giants left now. Okay. Right, so how are we doing? Are they all going to survive all in one piece? Looks like... So all that's left this time are the gas giants. Right, so how are we doing? Are they all fine? 17.1 Earth, so Neptune, that's fine. 14.4 on Uranus. Uranus may have lost a little bit. 0.189 on Jupiter. It's quite annoying that... Can we see it in Earths? 60.1. Interesting. And then Jupiter is 0.6. So Jupiter takes a lot more damage than the other gas giants, but its radius is still fairly... Yeah, its radius has managed to hang in there this time. But okay, interesting stuff that time. So another bigger star did it. So let's go ahead and open that up again. And I think actually what we can probably do is actually use the Planet 9 in our solar system simulation as well. So whereabouts was that? That was somewhere down here. Let's just go ahead and search solar system. Non-moons. We don't want any moon simulations. That would just be really, really slow. So we'll just use a good old... Or was it the evidence for the 9th planet could be quite a good simulation, actually, to use. Because it's got some really distant outer objects. So... Okay, so does this still have the Planet 9? I really hope this has all the other solar system objects in it as well. So let's see what we got. Or does it only start off at Neptune? I can't remember. Let's have a quick look. So is it going to open? Come on, game. A little quicker than that, please. There you go. Right, so, okay, this one only starts off at Neptune. But I guess that's a good way to test, actually. Will these really far out objects be affected by any of this? So, for instance, we'll do it with the sun again. But then we will put a large star in and see if they have any changes. So, let's just pop it. See if anything here happens. It looks like all those dwarf planets are fine. So, as we can see, the sun doesn't seem to be able to break into the outer solar system and damage many of the objects out there. So again, we'll run in the simulation again. It looks like we're going to have to search it up once more. So let's just load it in again. Okay, so this time, let's try a bigger star than Arcturus. So we had Arcturus before, was there. So this one, for instance, is 25 Sun. So what if we go to Vega? No, Vega's actually smaller. 7.3, 1.8. We need a larger star. Antares is a little too big. Pollux... That's still actually smaller than the Arcturus there. Yeah, we'll try Alpha. Yeah, okay. That one is a lot more mighty already, so delete the sun. So this one is obviously 0.23 AU, so if we put that in suns, 50 suns. So that's almost double the size of the previous one we did. So now, let's pop this one. Let's see if any of these dwarf planets get affected by that. No? No, said that? No? Okay. So it looks like these objects super far out don't get any problems from larger stars. Okay, I guess we're going to have to turn the limit all the way up now. We'll go back into the normal... we'll just go back into the Planet 9 solar system, so it has all of the gas giants. So where are I? Planet 9, thank you. Right, cool. So obviously that's got the Planet 9 orbit out there. So what we're going to do now, obviously this time, if we're going to use a large star, obviously it's going to destroy the inner planets instantly, actually. So why don't we use... Is Stephenson... Have they added Stephenson to the menu yet? I think we've got to try Stephenson. So we'll have to add our custom one in that case. I don't know if... I thought they added it to the game. Oh well. So Stephenson there. So obviously this thing breaks out the orbit of Saturn, which is just ridiculous. So there it is. So click play. That would obviously dissolve everything. Whoa, okay. That may not have meant to happen there. Okay, so obviously all that got dissolved. So Uranus is the next object out. Uranus and Neptune. So what we're going to simply do now is pop that. So I'm thinking surely this star would be able to blow up Uranus and Neptune at that range. So, oh, what is all that about? How did the star survive? That is beyond bizarre. How are these guys doing? No, they didn't seem to have any problems at all. That did seem a little buggy though. So let's try that again. So we're all about with these experiments. You've got to try it more than once. Just check you don't get anomalies happen. So we'll just keep running it and see if we can get a consistent result in what happens here. So what we'll do is we'll use one of the bog standard stars actually instead of the custom ones. Maybe the custom ones are a little more buggy. So we'll just use Canis Majoris. Why not? That's a cool one. So place that in there. That breaks obviously the orbit of Jupiter. So for instance, that would instantly dissolve anything in the inner solar system there. So now, for instance, we want to pop it. See, that's weird. Why doesn't the star delete itself? What is that? Let's just get rid of that. There you go. So that's how it should be, right. So another nova. Saturn, yeah, Saturn's not looking too hot now. See, that's losing mass a lot quicker. Uranus has already gone. So this is the result we used to see back in older versions. Uranus was always the first one to go because it had the least mass. So this kind of lines up with some older tests. So let's see how it goes. Neptune actually survived this one. 17.1, so Neptune didn't even get affected. Uranus just got just annihilated. Planet 9 lost a bit of mass out there as well, but again, not many dwarf planets are surviving that. So again, we'll run the test again with Canis Majoris. So let's just go back into the normal solar system this time, because the Planet 9 doesn't seem to make a difference anywhere. So let's just delete the sun. Quickly go for it again, see if we get any different results, or if it gets the same result again. So what we can do as well, we will slow down time a bit. So there we are. Right, and obviously we want to pop the star. There you go, cool. So click play, Oh, the music changed when I did that. That's interesting. Right, so play. How are the objects inside the star still there? That is just so strange. So popping the big stars does seem very, very buggy indeed. So let's let that rip. So let's see what is that all about? Why does the star not disappear? Because that's what should happen. So Jupiter somehow survived being inside the star. So yeah, maybe the big stars aren't so accurate, but this time Uranus actually survived. So mixed results once more. So it seems pretty interesting. But as we can see, most of the supernovas are destroying the inner solar system no matter what. So then maybe the gas giants are more are stronger against supernovas in newer versions of the game. That is quite interesting. So what I'm going to try next is if the rocky planets can survive, or the rocky objects can survive where Pluto is, what if we try the all moons? So where is solar system and all moons? Just planets. I can't even remember where it is. So let's just search it up. All possible dwarf planets. So we're definitely not opening that one. That one has got way too many objects in it. All planets and all moons. So let's try this one. So this should go out only to Neptune, I believe. Yes, right. So again, we're just going to pop the bog standard sun. So let's see what it does here. So I'm guessing all that. So I've already seen that all the moons of Jupiter have gone. Every single one just dissolved instantly. So that's not good. Saturn, I'm guessing the same problem as Saturn. Got a few of them still surviving at Saturn. Titan, they all just all broke off. Oh, look at that massive trail of stuff that just exploded. So that isn't good. So what's all going on here? So the moon's closer to Saturn, actually hanging on in there. What's that all about? Interesting. Uranus, I'm guessing they're all gone. Yep, all of Uranus's moons are gone. And I'm guessing, I don't think Triton would have survived out of Neptune, would it? Or has it? Oh, no, it has. It's hanged on in there. Well, it's hanging on in there. It's losing mass, though. Oh, dear. So Triton's hanging on in there. Come on, Triton. You can hang in there. Looks like it is. That is very glitchy indeed. Is it cooling down? It looks like Triton may actually... Yeah, Triton survived. Right. So let's still get a lineup of what survived that out of all the moons. So we've got all the gas giants. For some reason, Dione out around Saturn survived. I mean, that if Titan got destroyed, I don't think any of these moons should still be here. The only moon possible in that run would have been Triton. We'll run it again, though. Let's do it one more time before we finish up today, because I think we've done enough tests now, but you can rapidly see the consistency that inner planets, just no chance. Moons around Jupiter and Saturn didn't seem to like it either. Uranus, some of the dwarf planets did fade out, but other ones like Pluto, for some reason Pluto liked to survive, and obviously because Pluto is one of the most massive objects out there in the Kuiper Belt, other than Eris and Triton in theory, so... yeah, interesting stuff. So again, all moons. It's annoying we have to keep searching it. It used to just stay searched when you open simulations. Right, so let's try that again. So, nice and easy. Pop the sun. And let's just see what happens. See what results we get. So, does it keep all the objects up here? Or maybe they disappear after a while? Keep opening it and closing it so we get different objects. Triton's not looking as good this time. So that is bizarre. Right. So obviously the gas giants all... Why is Dione surviving in all of the small moons? That is very strange. Right, so how are we doing this time? So they've obviously all broken away. So some moons around Saturn survive. So maybe the Saturn moons are more glitchy. Are they all... I think those are all Saturn moons. All of those in there. Yeah. So for some reason Saturn's moons are more resistant to supernovas. There's an interesting fact in Universe Sandbox for you. So that is... What's that all about? That is bizarre. So as we can see, none of the gas giants, apart from Uranus, were disintegrated once. So, and Uranus only disintegrated when we put a larger star in. So it seems, yeah, the outer solar system is fairly tough against supernovas from the sun now. But yeah, there we go. So hopefully you guys enjoyed those little experiments for today's video. And if you did, make sure to hit that like button. Let's see if we can go for 50 likes on today's video, guys. And if you've got any other little experiments I should try, let me know down below in the comments or in my Discord server. But with that all said and done, guys, make sure you all have a great day. Stay safe out there, and I'll see you in the next video. Goodbye.